Hi, I'm Yizhuo Zhang, and my teammate is Qichao Qian, and our title is a contextualized time interval self-attention sequential recommendation systems for sequential recommendation. And our presentation will have three parts. Firstly, I will tell what is the recommendation systems and the history of its development. And then I will tell our contextualized time interval self-attention model. And I will show why we want to choose this model and how to get this model. And finally, I will tell the details in our implementation, and I will also show the result and analyze it. So firstly, what is a recommendation system? So generally, a recommendation system is a subclass of information filtering system that seeks to predict the rating or the preference of a user would give to an item. And there are three main types of recommendation systems. The one is the content-based filtering, and then the collaborative filtering, and the hybrid recommendation systems. And as for our problem is a sequential recommendation, and there are also some models used in the sequential recommendation. The first is the Markov chains. As we know, for the first order Markov chains, we assume that the item only relevant to the recent item. However, this assumption is not useful in our sequential recommendation problems. Therefore, we need to use the case Markov chains. And then it's the recurrent neural network, which we have learned in our classroom. This technique is widely used in the natural language processing problems. However, compared to the NLP dataset, the sequential recommendation dataset is relatively small and sparse. So the performance on sequential recommendation is very weak. So then it's the attention model, which we also learned in our class. So now the attention model is widely used to do with the sequential recommendation problems. However, as we know, generally the attention model only contains the item information. It won't have some other information. So now we can say there is a problem, and we will use this problem to show why we want to choose our model, a contextualized time interval self-attention model. So now we have a user, and we know in the history it's an online shopping problem. And 1 month ago, this user is currently browsing some items related to the sports. And well, 1 day ago, he just seriously examining the smartphone. So if now he wants to buy a watch, which kind of watch we should recommend to him? So based on the time information 1 month ago or 1 day ago, or the contextual information currently browsing or seriously examining, the inference may be totally different. So we think it's also important to add the time information and the context information. So here is a model we searched in the internet, a contextualized temporal attention model. And we can see in the picture that the first stage of the model is used attention to catch the item embedding and which to add the item information. And then it used the time kernel to catch the time information. Finally, it used the BiRNN and combined with the context features to catch the context information. However, in this paper, it just gave us the assumption, but it didn't implement the context part. And the time kernel it used is also very simple, and we think this time kernel it used is not have a good performance. Therefore, we first add our own context part combined with the BiRNN, and we also design our own time kernel which can match our data set. However, during our work, we find some shortage of designing time kernel. The time kernel for a specific dataset cannot generalize to other same kinds of datasets. And it's also hard to design a specific time kernel to match some datasets. Therefore, we may need to some other kinds of technique to add the time information. So they may have some temporal recommendation systems. One is the time SVD, which is splitting the time into several bins of segments and modeling users and items separately in each. While another is utilize the temporal information in existing deep recommendation models. Time gate structure to model the variable time interval as part of the recurrent state transition. Nevertheless, none of these models are developed especially for the sequential recommendation. So therefore, we find another which we think is a better way to catch the time information. It's a time interval aware self-attention model, and we will use part of this model to combine it with our own model to have a better performance. And in this model, it used the time matrix Pij to catch the time interval between item I and item G. And it combined the matrix with the attention model, which will help us to add the time information. But we should remember that before we're doing this, we need to sort the item at first, which can help us to retain the absolute position in the data. In this part, I will show the details of our experiment and analyze our results. So we use the movie lens dataset as our dataset, which is widely used in sequential recommendation problems. We can see in the picture that the first column is the number of users. We have 6,040 users. And the second column represents the movies. And then it's the movies rank of its user. And finally, it's the time steps. And we need to pre-processing some data here. And then we use normalized discount cumulative gain at turn and the hit turn to evaluate our model. Here is our experiment results. We can see in the picture that the first line is some traditional model, and the second line is our model and some similar structure. So the conclusion and analyze this. We can see in the picture that compared to the traditional technique, our model performance has a significant increase. However, the improvement compared with the time interval self-attention sequential model and the contextualized temporal attention model is weak. It may be because our dataset information is limited. The interaction type only has the rank of the movie. Therefore, the contextualized part influence in our model is relatively weak. If we have more information of interaction type, such as click or bookmark or delete, or we know the actor, we know the movie types, and so on, the result may be more different. And the additional contextualized part only contains the rank information. So we analyze that this part may have a small influence on our model based on our contextualized temporal attention structure. So our modification might have limited influence on the model's performance. So in the future work, we can use the ablation study to check which part is improvements is weak, and we may change the window size or time kernel to have a better performance. And it's also hard to avoid overfitting because our model is relatively complicated. Therefore, we may need to change some part of structure of our model. Maybe we need to delete some parts. And that's all. Thanks for listening.